Introduction. 12,000 years ago, according to our written history, the glaciers from the last ice age finally melted away, revealing the Britain we know today. For over 100,000 years, at the end of the Pleistocene epoch, Britain had been underneath 2 miles of ice, compressing the ground by its sheer weight, so much so that the land surface was then some 20,000 feet below its original level, which has consequently risen back slowly to become the landscape we know and are familiar with nowadays. Geologists have assumed that these glaciers melted due to warming in climatic conditions, creating a series of meltwater pulses over a short period of time. But they have failed to date to produce a realistic model that fits the total meltwater discharge, which eventually created not only the North and Irish Seas, but the hundreds of feet of sea level rises that we are still experiencing today. If you study any British Geological Society map of Britain, you will notice it shows a series of bedrock, sedimentary, and superficial deposits. Below these deposits is a labyrinth of material that look like canals and gigantic waterways which lay under the surface on top of the bedrock, which is the remains of paleochannels from the last ice age. This evidence is a testament to how the landscape would have looked when the rivers were at their highest and when they were discharging at their maximum levels. These superficial deposits that resemble ancient rivers can be seen on the surface and are known to archaeologists, geologists, and the general public as dry river valleys, because the river valleys today are currently dry. These great waterways can be readily seen in profile in the cliffs and valleys of the South Downs, where they show their curved river nature by the remains of the superficial subsoil consisting of sand, silt and clay. Past geologists have failed to identify these huge concave broken chalk sections of the cliffs accurately, or to date the river terraces deposited from the remains of the meltwater of the last glaciation maximum, as they have historically only identified the gravels and bedrock within geological periods. Their arguments are compounded as they fail to explain why they are relatively short distances from the sandy silt to today's topsoil, or why silt and sand are at elevations above supposed earlier river terracing, so they suggest these deposits are wind-blown loose, blown into position, rather than deposits laid down by rivers of the past. This book uses existing scientific evidence from peer-reviewed publications and modern mathematical models to give you an understanding of how the landscape looked in the Holocene period, giving archaeologists the tools to reveal fresh discoveries and a better understanding of our history.